Today is Monday, August 29th, 2022. It is also day 405 of data science, and today I'm going to take this context provided by Khan Academy. And it's just like middle school student heights when normally distributed with a mean of 150 centimeters and a standard deviation of 20 centimeters. And basically, I'm just going to take a random sample from that normal distribution given the mean and standard deviation, and I'm going to turn those values and insert them into a pandas data frame so I can plot the histogram of those values and so I can see, a normal distribution. So the first thing I'll do is import NumPy as NP, and NumPy is just kind of like a numbers library. I like to think of it. It's in the name NumPy. So what I can do is I can set my values equal to np.random.normal. So I'm basically getting random numbers from a normal distribution, and it takes in three parameters. It takes in the log, it takes in the scale, and it takes in the size. So the log is the mean, the scale is the standard deviation. So I'll just go and set up the mean here and the standard deviation here. So 20 centimeters and mean 150 centimeters. So I can just pass in the mean here as a variable and the scale over here as a standard deviation. And then the size is the kind of format that you want your output to be. So np.random.normal returns an array, and essentially it could return an array with like two columns, one column and 500 rows and whatever. But if I just want 500 rows and I run this and put values in, I'll get an array of 500 numbers, or in this case, within the context, 500 middle school student heights. If I want, let's say, two random samples that I can plot in pandas later, I can do, okay, I want 500 rows and I want two random samples, or like two columns. So it's going to give me two columns with 500 middle school student heights. So you can see two columns right here. And if I do like three and so on, it's just going to keep increasing the number of columns. And I'll get three columns with 500 random numbers, which in this case is random middle school student heights. And it's just, Python is just like generating these numbers, but they're based on the normal distribution with the mean and standard deviation that's given in the problem. But I just want 500 values. I only want one random sample. So I'll just do that and X out of that. And by default, it's only going to give me, it's not going to give me a column. If I do one column, it's going to give me one column, right? But then it becomes a two-dimensional array and not a one-dimensional array. And then it's going to have some problems importing it in pandas. And I'll show you. Let me try to do that right now. So if I do import pandas as PD, pandas is a data analytic library, so it has to do with, reading in data, analyzing data, wrangling data, and so on. I'm going to create a variable data frame, so df, and I'll do pd dot data frame. And I can pass in a dictionary, the first value being the column name, so I can be like sample1. And then the second would be the actual, what would you call it? The actual values. So I can run that, and it's going to give me an error because it's a two-dimensional array, and Python only does one-dimensional array. So if I were to just change this to be 500 and run that, then it would actually work. And I'll be able to see my data frame over here, sample one, blah, blah, blah. But because I put in, like, I specify a column and put like one, it's not going to work. Let me just get rid of values so it stops printing out. So again, if I run it, it's going to give me an error. But if I were to do this, and let's say I wanted to have multiple columns, like let's say two columns, I could definitely plot this in a pandas, not plot this, insert or convert this as a pandas data frame by simply just getting rid of the dictionary and then just writing in the values that I want and then passing in names for the columns. So I can do, let's say like sample one or sample A, and then I could do sample B. Get rid of that semicolon, and then run that, and then here you go. Now pandas does take in two-dimensional arrays. I think in this case it would be three-dimensional, maybe, whatever. It's more than one dimension. That's what it matters. And you can have, your columns, which is pretty cool. But yeah. But currently I just want just 500 values because I'm only going to plot one sample. So now it's going to give me an error because I don't have one column. It also works if I just do that also. That's just another way because I'm giving, this a name. It's another way of just saying, just passing in a dictionary, doing sample A, and then putting in the values here. Same thing. All right, and the next step is to plot this distribution, the distribution of middle school student heights. So maybe I just want to be more specific and be like middle school student heights. Probably, that's not how you spell heights. Heights in centimeters. Run that and I'll be able to see that. And then if I want to plot it, I can just import Seaborn because that's the graphing library I like to use. And then I can do sns.hisplot. And then just target what I want to plot. So I want to plot the data frames middle school students' heights, run that, and I'll be able to see the histogram, which is pretty cool. And I can see it's kind of slightly skewed right. So maybe there's some outliers where some students are higher or have a higher height or a larger height. How would you say that? Larger height than others. But yeah, that's it. And that's pretty cool. And if I want to add a title, I can just do plt.title. Well, first of all, I have to import matplotlib to use plt. So import matplotlib.pyplot as plt. Okay, where did everything go? Pyplot. What is going on? Pyplot. Okay, there we go. That's a long one. Anyway, then I can do plt.title and just put in the distribution of normal, not of normal, of middle school student heights in centimeters. Or probably just get rid of that and then add an X label. So now I can see that. And then I can do, hold on, plt dot, you might be wondering, why did the graph go away? We'll do that in a second. So plt dot title, plt dot X label, and then put just student height or just height in centimeters and run that. And I'll be able to see that. Let me just run it from the beginning, everything. Probably move this towards the same line that this is in, and then have this in the same code snippet that this is in, and delete that, and then run it from the beginning again. And notice that the graph changed because again, I'm basically getting different set of random values every time I do this. There we go. So tip of the day, have everything in the same code snippet. So yeah, this is the graph distribution of middle school students' heights. And then we have the height, we have the distribution. We can see it's frankly normal and that the mean is like it's centered around the mean, which is, what is it again? 150, 150 something? 150. And then each of the students' heights deviate 20 centimeters from the mean. So yeah, that's it for today then. Bye.